So we've done quadratics. Do you remember that? The U-shaped things, like y equals x squared, like looks like this. Then we have y equals minus. Again, you can have a bunch of things in front of the numbers, but the main idea is it's a U, yeah? X squared, quadratic, it's a parabolic shape. Goes up, comes down. This point here, if it's going up like this, if it's opening upwards, that's a minimum, right? Here, what is this called? That's a maximum, okay? Because you'll never get a y value higher than this point. This is called a vertex. Vertex, it has some x value, it has some y value. In both of these cases, what's the x value here? There's no numbers, but it's on the y-axis. For any given point, yeah, on the y-axis, what's the x value?
0.
0, exactly. So we don't know what the y value is, but they're both 0 y's here. Second of all, that is a function, okay? Like what exactly is a function? Because this is gonna matter here. Function means you have some f of x, and then you have some equation here, okay? That's the algebraic way of writing it, but then there is a graphical way of writing it as well, like denoting it, which is a function is any curve, okay? A curve or any shape, doesn't really matter, any shape. Let's look at this. This is the sine curve. So how do we know if this is a function or not? What we do is we do something called the vertical line test. So you draw a line, yeah, anywhere. If that line only crosses through one point, then that's a function, okay?
Okay.
Compare this with maybe like a circle. If you draw a vertical line here, look at this, it crosses it once here, and then it crosses it twice down there. A circle is not a function, okay? Circle is not a function. So when we talk about x squares, that is called a polynomial function. What's the name of it? Polynomial. And it comes from a family of polynomials. And the notation is always going to be something like this. X squared, x3, x. You see all these are polynomial functions, okay? And this is going to be the rubric. You have x as the base. And then you have some power, right? The power must be a whole number. Like you can't have x to the power of 1.5. That is not a polynomial. That is a function, but it is not a polynomial function. It needs to be a whole number that is greater than 0 or equals to or greater than 1. For example, x to the 1. This is where it starts, okay? So where it starts. So the power itself cannot be negative, and it also cannot be a fraction or a decimal or anything like that. It has to be a whole number. Cool?
Okay.
But you could have some number in front of it though. For example, you can have 3. This is okay. That's a polynomial function. You could have root 3x. It doesn't matter. This is just the coefficient. Constant in the front does not matter. It's just up here, you can't have a whole number or not, okay? Now here, we're just gonna do a couple of these. Actually, just let's look at this table. You'll see what I'm talking about. So are they a function or are they not a function? Or polynomial functions, okay? Look at this one, 3x squared, 5x plus 3. We have, what's the degree of this function? Degree means the maximum power.
2.
2. This is a degree 2 polynomial, meaning it's a quadratic, yeah? Is it opening up or down?
Up.
Yeah, because of the 3, okay? You always look at the number in front of the highest degree, so this is opening up. That 3 there, that's called the leading coefficient, because it's attached to the degree x. Okay, and this is opening up. What about the second one here? What's the degree here?
7.
7. What's the leading coefficient?
Up.
What's
It's
the?
5.
It's 5, exactly. So notice all these guys, they all have x to the power something, yeah? And all these powers, they're always 1 or higher. Actually, it doesn't actually have to be 1, does it? 0 or higher. What's going on with the -7 there? Is that a polynomial?
No.
It actually is, because it has x to the power of 0. 0 is also good, because x power of 0 is just a 1. Okay,
Oh, okay.
so that's also actually a polynomial function. All of these are functions, polynomial functions. Now let's contrast this with the guys on the right side here. You have root x. What is the power of this x here?
0.
Root, what does root mean? If you write it in exponential form, right? What does root mean? It's to the power of what? To the power of 0.5, or 1/2, right? It's the power of 0.5.
I'm sorry, someone came at my door.
It's okay. So root means it's to the power of 0.5. Is that a whole number?
No,
No, it's not. Is this a polynomial function?
it's not.
It's not, right? Because of this. What about here? For the second one, what's going on there?
It's under 1.
It's in the denominator, right? So if you bring it up, you're gonna get x to the power of -1 somewhere. Okay? Is that a polynomial?
No.
No. You'll get 2x to the power of -1. That's not it either. So that's the difference. Here, this one's a -1, no good. Here, this, you have something over something. That's actually called a rational function. Looks very weird. Okay? Because there's something on the top, something on the bottom. No good. What about here? 4 to the power of x.
No.
Right. What's going on here? What kind of a function is this? It is a exponential function, okay? Because the unknown, the x, is in the exponent. What about this sign thing? Is that a polynomial?
No.
No, it's a trigonometric function, trig function. And here you have multiple variables going together. That's also not a polynomial. There's also a -2 here. Here there's a 2.5. So that's how you distinguish if something is polynomial or if something is not polynomial, okay?
Okay.
Now, y equals x to the power of 0. Is that a polynomial or no?
It is.
It is. What does that look like? What could that possibly look like? That is y equals, what's x to the power of 0?
0.
No, x to the power of 0 is not 0. X times 0 would be 0, but not x to the power of 0. It's 1, right? What does the graph of y equals 1 look like? Do you remember this? We did this. There's 2 variations. So you can either have x equals 1 or y equals 1. What does that look like? So y equals 1 is just a horizontal line through 1. That's it. So this is y equals 1. Similarly, x equals 1 would be a vertical line through, like this, okay? But this one, if you do a vertical line test, it's gonna fail. That is not even a function. Not forget about polynomial. That's not a function. We're not interested with that. Now the next thing is y equals x, right? Y equals x. Now what does that look like? Looks something like this, straight line that goes through the origin, yeah?
Mm-hmm.
Then you have y equals x squared. That has a shape, we've done this many times, like this, a u through the origin. Now the question is, what does y equals x3 look like? We have x0 here, we have x1 here, we have x2 there. Any ideas what x3 could look like? It's gonna look like this, okay? And the pattern is gonna follow. It's gonna start down here, all right? It's gonna start down there, it's gonna go through the origin, and then it comes back up like that. This is x3. This is all the weird shape, okay? This is the weird shape. Now x4, what does x4 look like? Now x4 looks exactly like x squared. It's just a little bit fatter here. It gets fatter and fatter and fatter. See, that's x4, okay? What does x5 look like? x5 looks exactly like x3, but it's just fatter. Again, around the origin, this red one is gonna be x5, okay? So new shapes is basically just this one, x cubed. Because x4 looks exactly like a quadratic, and then x5 looks exactly like this fatter, and same thing, the pattern just keeps on growing. x6 is the same thing as x squared and x4, just fatter around the origin there. Okay? And notice they all pass the vertical line test. They're all polynomial functions. Let's see what questions they have for us. It doesn't have to just look like that though. Like this is the basic case, okay? You see this shape here? This is y equals x3. This is called a parent function, but it doesn't have to look like this. It could also look something like this. An example of this would be like 2x3 plus 5x squared plus 3x plus 9 or something. The main idea is that it's going to start down here. It is going to end up there, okay? You can also flip this. You can also flip this. For example, what does a graph of y equals minus x cubed look like? So instead of going from, these are called quadrants, okay? First quadrant, second quadrant, the third quadrant, the fourth quadrant. Negative x3, instead of going from 3 to 1, okay? It goes from 2 to 4. There's a reflection on the x-axis. So it's going to look like this. This is the graph of a negative x cubed, the parent function. But then you could also have something like this. That's also x cubed, but then there's going to be some other things going on in that function, okay? So there's two types, right? There's like odd polynomial function, which means x1, x3, x5. And then there's even polynomial function, which means x squared, x4, x6, yada yada. Look at this one, odd one. This is going to be a potential graph of x5, but not just x5, there's going to be a bunch of other things attached to it as well. So x5 plus 3x4 plus yada yada all the way to some constant y-intercept minus 8 or something. What's the degree of this polynomial?
5.
5, right? It's 5. Now, what does that have anything to do with it? Look at the number of turning points here. We have 1 turning point, 2 turning points, 3 turning points, 4 turning points, yeah? So the number of turning points you can have for a degree 5 polynomial is always 1 less. Any odd polynomial. For any odd polynomial, the turning point, we can call this TP, turning point, it's always going to be n minus 1. What's n? N is the degree. Okay? And this is the max turning point. This is the max turning point. Like it could potentially only have 2. And that could also be an x5. See something like that? That could also be an x5. But the max number turning point is n minus 1. Okay? Could it have no turning points? What do you think? Does this have any turning point? x3 here. Turning point means it has to do there has to be a parabolic shape somewhere. If you zoom in on it, right, you're gonna get a quadratic. Does this have any turning points?
No.
No, it does not. So you can have 0 turning point, okay? But the max is gonna be n minus 1, okay? Max is gonna be n
Okay.
minus. Contrast this with the even one, x squared. And a potential x4 would be, it's the same idea. It's gonna max is gonna be n minus 1. So it could have 3 turning points like this. 1, 2, 3, okay?
Mm-hmm.
The only difference is, can it have no turning points? Because for the odd one, the minimum number of turning points was 0. It could potentially have no turning points. But for an even one, look at this, even x squared, it must have at least 1. At least 1, okay? But maximum of n minus 1, that depends on the degree. So for example, x power 6 can have 5 turning points. 1, 2, 3, 4, 5. Yeah, this could be a potential graph of x power 6. It needs at least 1, whereas the odd functions, they don't need, okay? That's idea number 1. Idea number 2, for any polynomial function, for any, doesn't matter what it is, for any polynomial function, the domain, okay, domain means the possible x values it can have. The domain is from negative infinity to positive infinity. That means all the x values that you can think of is part of that function. Okay, it's continuous. That's what it means. Like it keeps going here to like a billion, to like a trillion. It keeps going. It never stops. Same thing for an even function. For any polynomial function, on the x-axis, it goes to infinity on both ends. There's negative infinity here, positive infinity here. It's going to keep stretching towards them. The difference is going to be in the range. So for odd, it's going to have a different range. Range means now the possible y values it can take, yeah? Like look at this quadratic. Can the y value ever be negative 1?
No.
No, right? What's the minimum y value? 0, right? Because this is x squared. So the range for even function, it depends on this thing. The vertex, it depends on the vertex, okay? The range for even, in this case, it's gonna be y is greater than 0. Maybe we have something like this x power 4, and maybe this is the minimum value, okay? Maybe that's minus 4 on the y. This is minus 3 on the y. What's gonna be the range of this function? It is going to be y is greater than equals to negative 4. Y has to be, that's the minimum value, okay? It can be negative 3, negative 2, or 10 billion, but it'll never be negative 5. Contrast that with the range for odd functions. It's the exact same thing as its domain. Range can be anything. It's going to be from negative infinity to positive infinity. Like, look at this point. This could be like negative 10 million on the x, negative 10 million on the y, and it's still going down. So it could go to negative 20 million on the y. Same thing up here. So the main idea, domain is for any polynomial function, doesn't matter odd and even, it's going to be from negative infinity to positive infinity, but the range for odd is the same thing as its domain, negative to positive. Range for even, though, depends on its minimum or its maximum value, okay? Depends on its vertex, the extreme value that can take. All right, here, check this out. It says, which one of these represents a polynomial function? What do you think for A? Is that a polynomial? Polynomial, what does it mean? It means x squared, again, it can be negative as well. Plus minus x cubed, yada yada. Does A fit into any of those? Okay, I'm gonna give you a hint, okay? Yes, it is. Yes, it is a polynomial function. A is. How do we know that? Look at this. It's going, look at the domain. The domain of a polynomial function is it can be everything, right? See, these lines, they extend indefinitely to the negative and positive infinity on the x-axis. Now count the number of turning points. 1, 2, 3, right? We know the max turning point is n minus 1. So what's the power of this function? What's the degree of this function?
4.
4. So this is minus x4. Why is it minus? Because it's opening downwards. Okay, so it is a quartic. The name for 4 is like how 2 is a quadratic. 3, power 3 is called cubic.
Okay.
Degree 4 is, these are just names. This is called quartic. So this is a degree 4 polynomial that's opening downwards. What about B? Is that a polynomial?
No.
Yes, it is. 1 turning point, 2 turning point, okay? The domain is gonna be from negative infinity to positive infinity. And the range, yeah, look at it. It's opening one place and it's closing somewhere else on the other side. Whereas this one, it was closing in the same area, right? This is, if there's a discrepancy here, that means it's an odd polynomial. In fact, it has 2 turning points. What's the degree of this?
3.
Yeah, exactly. This is x cubed. Is it positive or negative?
Positive.
Yeah, exactly. So it's positive x3. That's all there is, okay? What about C?
It's not.
It's not. What is it?
Um.
It is an exponential function, okay? Has this format, some number to the power of x. That is an exponential function. It is not a polynomial. How, another way to distinguish this, look at this. There's an asymptote here. There's an invisible line. Notice how that graph is never going below this line. Okay. So that is not a polynomial. That is an exponential function. What about D?
It is a polynomial function.
Yeah, what's the power?
2.
Yeah, it's just positive x squared, positive because it's opening upwards, okay? What about E? Is that a polynomial function?
No.
No, it's not. How can you tell? Because it doesn't fit in our domain, right? It doesn't fit in our domain. What does this mean? This means, look at this. The x value is not gonna be, if you look at the graph, it kind of stops at 0. Okay, it's not going beyond 0, so that means it's not, the domain is not this. So this is not a polynomial function. This is actually the square root of x. Okay, it's a square root function. What about f? Is that a polynomial?
Yes.
Okay, how can you tell?
The line keeps like going on.
Right, so actually f turns out it is not, okay? Now, why is it not? It fits the domain criteria, okay? It fits the domain criteria, but it doesn't fit the range criteria. So if it's an odd function, right? If it's an odd function, the range, what's the range for an odd function? Odd polynomial. Like this, what's the range of x cubed? Range means the possible y values it can take.
2.
3?
2.
No. Range means the possible y values. It's gonna be from negative infinity to positive infinity.
Oh.
Can be anything, right? Same thing for its domain. It can be anything. Well, domain for is everything. This f here, this one on the x on the domain, x is for domain. Yeah, it fits the domain criteria. But if you look at the range criteria, for an odd function, it's going to be from negative infinity to positive infinity. And this is not even close to that, right? See, it's kind of stops It's never even -2. So it's definitely not odd, right? Definitely not odd. Now for it to be even, yeah, it either needs to be y is greater than something if it's opening upwards, or y is less than something, right? That means either it has to keep going up from some value, or it has to keep going down from some value. It doesn't do this. It's strictly, the range for this one is strictly between -1 to 1, you see? It's not indefinitely going down for an even function, nor is it -infinity to positive infinity. So this is not a polynomial function because there is a restriction on its range, which doesn't fit into either one of those.
Okay.
In fact, this is y equals to the graph of sine x. Y equals sine x, okay? Which we'll get to some other time, but yeah. All right, here, look at this 2-second answer. Is a polynomial function?
Yes.
Yes. What's its power? What's the degree? 3. You're right. What about B? Polynomial or no?
It is.
That's a quadratic, right? X power 2. What about C?
No.
C is not? Yes, it is. It's a linear function, x power 1. It's good.
Oh, okay.
Yeah, 2x. The x is power 1, degree 1. It's good. What about D? Is it or no?
No.
No, it's not. It's to the power of 0.5, right? If you write that in exponential form, square root means to the power of 1 over 2 or 0.5. So cannot have a decimal. D is out. It is not a polynomial. E.
Also no.
Also no, because there's something on the top, something on the bottom, right? It is not a polynomial. F.
Yes.
Yes, good. What is its degree? Now this is, you're gonna run into some issues there. What's the degree of that polynomial f?
Um. 2.
Good try. No, it's not. It's 3. Here, let me show you why it's 3. What is x minus 1 squared? If you open that bracket, what do you get? I just want to open this bracket. So basically the question is, what is x minus 1 times x minus 1? That's what the square means, right? How do you do something like this? We need to FOIL it.
Do you multiply everything with x?
So we're just trying to open this bracket first. This x on the outside is right here. Okay, look at this. You do it like this. You're gonna have to FOIL this. First, you do x times x. Okay. What's x times x?
2x?
No. X times x. X plus x would be 2x.
Oh.
X times x.
Power 2?
Yeah, exactly. X to the power of 2. So you do it like that, x times x. And then you do x times -1, which is gonna be minus 1x, right? And then you go to the other term. -1 times x is -x again. And then you do -1 times -1, it's +1, like that, okay? Any like terms here?
The x's?
The x's, so we can add them up. So we get x squared minus 2x plus 1. So that's what x minus 1 squared is, okay? Now we have an x on the outside. Let's open this. Again, you do it just like we did it here. What's x times x squared?
X cubed?
Yeah. What's x times -2x?
-2x to the power of 2?
Yes. What's x times 1? Well, that's just x. There we go. You see this, actually, when you open it up, this is a degree 3 polynomial. It's a cubic function. Okay, but you don't have to do it like this. Here, let me show you a shortcut. You can have something like x minus 3 to the power of 5 times x minus 2 to the power of 3. What's the degree of this polynomial? And the trick is, it's very simple. From x minus 3, you get x5. If you open that bracket, okay, This is the biggest thing you can get out of this, right?
Mhm.
What's the biggest thing you can get out of this? It's gonna be x cubed. What's x5 times x cubed? x8. You add the exponents. There we go. This is a degree 8 polynomial.
Okay.
Here, try this. We have x times we have x minus 1 squared times we have x minus 3 cubed. What is the degree of this entire polynomial?
5.
Nope. You didn't add the first one. You get x
Oh,
squared from second, x3 from the first, but then there was already an x1 to begin with, right? So what is it at?
6.
6, there we go. It's an even degree polynomial, okay?
Okay.
You don't actually have to open it. Like, it can get very tedious when you multiply the same bracket 5, 6 times. Let's see what we can do. All right, let's look at one of these guys. So what is the degree? There's an equation given down there, yeah? What is the
Mhm.
degree of this polynomial?
6.
6, right? What is the leading coefficient? Wait,
2.
yeah. Well, how many turning points?
5.
2, 3, 4, 5. Yeah, it has 5. And then what else do they want? Let me see quickly. Is it even or odd? Well, 6. That means it's even. Yeah, even degree.
Mhm.
Okay, now we're gonna have to talk about something new. Gonna have to talk about end behaviors, okay? End behaviors. So what does that actually mean? So to find end behaviors, you just look at where the arrows are, okay? Where the arrows
Mhm.
are. Notice how both of those arrows are going up, okay? So as x goes towards positive infinity, okay? Like, we take
Mhm.
this arrow, we extend it all the way to positive infinity. As x goes towards positive infinity, where's the y going? Where are the y values headed? So we go all the way here. You see this? We take this. Right now, on the x, it's positive infinity. Okay, on the x.
Mhm.
What's the y value here? Where is it headed? It is headed to positive infinity as well, right?
Mhm.
It's all the way up there. So this is called end behaviors, okay? So on the right side, as x goes to positive, this is it. It already implies it's on the right side. As x goes to positive infinity, the y values are also headed to positive infinity, all the way up there. They're getting bigger and bigger. That's what it means. As x gets bigger, y is getting bigger, okay?
Mhm.
What about on the other side? As x goes to negative infinity, where's y headed? So we're looking at it this one. Or we can look at it like here. So let's say that's negative infinity on the x. Where's the y?
Is it also going towards negative infinity?
Positive infinity. See up here, the y value is up here, right?
Mhm.
It's headed towards positive infinity, okay?
Okay.
So that's how it works, right? And it's different for even and odd here. Let's just do a couple of these guys. So here, this is 1, 2, 3. 3 turning points, it's x power 4. Is it positive or negative x power 4? It's positive if it opens up. It's negative if it opens down, just like a quadratic. Is it opening up or down?
Down.
Down. So this is going to be a negative degree 4 polynomial, okay?
Mhm.
Now again, look at this, right? Look at this. There's negative infinity on the x here. There's negative infinity on the y here. There's positive infinity on the x here. So end behaviors, you're always going to write this line no matter what. As x goes to positive infinity, y is going something. As x goes to negative infinity, y is going somewhere, okay? This is always going to be the rubric for end behaviors.
Mhm.
Okay, why don't you try tell me. As x goes to positive infinity, where's the y headed? So we're looking at this arrow here, right?
Negative infinity.
Yeah. As x goes to negative infinity, where's the y headed?
Is it also negative?
It is also negative, that's right. And this is always going to be the case with these even degree polynomials. Their end behaviors are the same.
Mm-hmm.
End behaviors are the same. What does that mean? That means wherever, doesn't matter where x is headed, y will head to the exact same place, up and down, okay?
Mm-hmm.
If you say negative infinity up here, then it must be negative infinity down there because it is an even degree polynomial x power 4. Now contrast that with something like, I don't know, 1, 2, 3, 4. Let's give it 4 turning points. What's the degree of this polynomial? There's 4 turning points.
5.
Yeah, it's a degree 5. Positive or negative?
Negative.
Yeah, good. It's negative. So this is an odd degree polynomial, right? And we're
Mm-hmm.
gonna look for our end behaviors, right? And again, the rubric is this: as x goes to positive infinity, as x goes to negative infinity. Now let's look at this one. As x goes to positive infinity, where's the y headed?
Negative infinity.
Yes, y is headed negative infinity. What about on the other side? As x goes to negative infinity, where's the y headed?
Positive.
Yes, good, perfect. Positive infinity. So what's the difference? For odd degree polynomials, the end behaviors are different. They're in fact the opposite. Okay?
Mm-hmm.
Are opposite. Notice how the sign flips here. Cool. So that's called end behaviors, okay?
Okay.
So it depends on if it's even or odd. Um, Now let's make a distinction here. When I say even and odd, I'm talking about the degrees, okay? Like x power 3 is it's an odd degree polynomial, okay?
Uh-huh.
Odd degree. Now there's a distinction here, odd degree polynomial, between degrees and functions. Odd degree doesn't mean it's an odd function. Let's look at this. Odd functions now, functions. And even functions. Like x4 could be, it's an even degree polynomial for sure, but we don't know if it's an even function. Now, how do you make that distinction? Even function is something that is symmetrical about the y-axis, you see? Whatever you have here, if you chop it in half, you have the exact same thing here. So x2, x4, x6, all these guys are even degree polynomials, but at the same time, they are also even functions, okay?
Mm-hmm.
Odd functions, on the other hand, they're symmetrical about the origin. So something like this, x power 3 is an odd function, okay?
Mm-hmm.
Y equals x is an odd function. So for an odd function, whatever you have down here, it kind of flips over to the other side, like diagonally.
Okay.
You can also do that on the other side, like for whatever you have here, you have down there. You see, this is an odd function.
Mm-hmm.
There's also something like this. This is called cosine x, y equals cosine x. See, it's an odd function. Oh, sorry, I messed that one up right now. No, I meant to draw this one. The sine function, which looks something like this. See, whatever you have down here, you have it up there, sine x, that's an odd function. Even function is if it's symmetrical about the x-axis. Like this is the graph of cosine x. And it's
Mm-hmm.
nicely chopped in half in the middle on the y-axis, okay?
Uh-huh.
So something can be an even degree polynomial, but at the same time, that doesn't necessarily mean it's an even function. Let's quickly check this out. 3x cubed plus x4 plus 5 or something like this. We know this is a degree 6 polynomial, yeah?
Mm-hmm.
It's even degree polynomials start there and there. Could have something like this, okay? Something like that. Is this an even degree polynomial?
No.
It is an even degree polynomial because the degree is 6. 6 is an even number, okay?
Oh,
But is it an even function?
no.
No, it's not. If you chop this in half, you get nothing, right? There's no similarity. You have all these things going on here. You don't have any of those. So this is an even degree, okay? Because degree 6, that's good. But it is not an even function because it's not symmetrical about the y-axis. Okay? Kind of makes sense?
Yeah.
And whatever the degree is, by the way, whatever the degree is, that is the maximum number of x-intercepts, which are also called zeros, okay? Zeros mean the x-intercept. Like, for example, if you have a degree 6 polynomial, then the maximum number of turning points is 5, but the maximum number of zeros or x-intercept is 6. x6, 6 possible zeros, okay? Let's look at this one. It says, describe the end behaviors of each function. Let's look at A. What's its degree?
5.
Yeah, degree is 5, right? Is it opening up or down?
Down.
Right, it's degree 5 and it's opening down. Leading coefficient is 3, right? What's the maximum number of turning points?
4.
4, good. Max TP, we'll call this, is 4. What's the maximum number of zeros?
5.
5, right? 5. What else do they want? End behaviors. So we know this is degree 5 and it's a negative. So it's going to start here and end there, okay? Degree 3, 5, 7 doesn't matter. If it's negative, it's going to start in quadrant 2 and it's going to end in quadrant 4, okay? What is the y-intercept? Y-intercept is in negative 5, okay? Negative 5. So we know there's a y-intercept of negative 5. We don't know where the zeros are. We don't really care. But we do know there's going to be 5 maximum zeros. So 1 0 there, 2 0 there. Boom. Now let's see if this fits the criteria. We have 1, 2, 3, 4, 5 zeros. Yeah. So that's a check mark there. And then at the same time, we have 1 turning point, 2, 3 turning points. So there you go. Okay. Now tell me the end behaviors for this. As x goes to positive infinity, where's y headed? Look here, right? As x goes to positive infinity, where's y headed?
Negative.
Yeah, exactly. Y is going downwards. What about on the other side? As x goes to negative infinity, so you look up there. Where's the y headed?
It goes to positive infinity.
There you go, perfect. And the end behaviors for odd functions are not odd, sorry, to maybe rephrase, odd degree polynomials, the end behaviors are different. Is this an odd function? Look at the graph.
No.
No, it is not, right? It is not. What we don't have the same things on like up here and down there. That is not a odd function. Cool. But that's the distinction between odd and even. Let's do B. What's the degree?
4.
4. What's the leading coefficient?
2.
Opening up or down?
Up.
Up, right? What is the number of turning points, maximum turning points?
1.
Maximum turning point. It's always n minus 1, okay? 3 turning points max.
3. Okay.
Minimum would be 1. Minimum would be 1. What's the next thing? Zeros. What's the maximum number of zeros here?
4.
4, exactly. And we know it's opening up. So for an even degree polynomial, if it opens up, last time it opened up here and down there, 2 to 4, because it was negative odd. Positive even is 2 to 1. Okay, it's gonna start here, it's gonna end there. We know the y-intercept is 2. It's gonna go through this, and we know that it can have 3 x-intercepts. So there we go. Sorry, 3 turning points, 4 x-intercepts. 1, 2, 3, 4 x-intercepts and 3 turning points. What are the end behaviors? As x goes to positive infinity, where's y headed?
Negative. Positive.
Yeah. What about when x is going to negative infinity? Where's y headed?
Positive.
Yes. End behavior for even degree polynomials are gonna be the same, right? So as y goes to positive in one direction, y must go positive in the other because it's a even degree polynomial. Cool? Cool, cool. All right, here, check this out. What could the graph of a polynomial function that has a range of this? Now, what does this mean? The YER doesn't mean much. It just means y is a real number. Like you can't throw some other numbers. Like you can't throw complex numbers in it, which is a completely different topic. Don't even worry about it. But the other part is important where it says y is less than and equals to 10, okay? It has 3 turning points. So what's the degree?
4.
It's degree 4, right? What is the maximum value? Or the minimum value? Is it opening up or down? If you look at this, this tells you if it opens up or down.
Up.
No, y is less than 10 means 10 is the maximum value, yeah? 10 is the maximum value. Y is less than 10, so it must be opening down. It can never be 11, right? Y is equals to 10. It can never be 11, but it can be 987 all the way to negative infinity. So 3 turning points, we know the maximum value is somewhere here, 10. If it's a negative, this one, instead of starting from 2 to 1, it goes from 3 to 4 like this, okay? And then boom, 3 turning points. So 1, 2, 3. And there we go. That's the possible sketch. And we can say this point is negative 3 comma 10 because the maximum value is 10, right? Yeah. So what can we say here? Well, we can say that it can have 4 maximum zeros because it's a degree 4 polynomial, right? And we can also say it's even degree. And we know that it's opening downwards because there's a restriction on the range. Y has to be less than means it's opening downwards. If it said y was greater than, then it would be opening upwards, okay?
Okay.
And there you go. And then this thing automatically tells us it's an even degree because for an odd degree polynomial, what's the range for an odd degree polynomial? Like an example, what's the range for this guy? What's the possible y values? It's negative infinity to positive, and it can be anything, right? At this point, it can be here, it keeps going down, so it can be any number that you can think of in the negative direction all the way to the positive, okay? So the fact that it gave us a restriction on the range, we automatically knew it was an even degree function. And the fact that it's less than means it's opening down because it can never be 11. That means it must be opening down. So that's the logic behind doing like deciphering some of these questions, okay? Okay, look at D. What is the degree of this polynomial? Actually, yeah, let's just jump into D. What is the degree of this polynomial in D?
Is it 1?
It's not 1, no. So here, let me pull this. What do they want? They want leading coefficient, degree, and end behaviors. So no, it's not gonna be 1 because you gotta take into account all the x's, right? Like you gotta open this, open that, open that. Oh, we don't have to open it. Like just think about it logically. From the first bracket, we can pull out an x1, right?
Mm-hmm.
From the second bracket, we can pull out a 3x1. From the third bracket, we can pull out this. And there's a 2x on the outside, right? Like that. Now multiply all of them. What do you get? How many x's?
4.
4. So you have x4. And you can also multiply all the numbers to get the leading coefficient. So 2 times 3 times 4. 2 times 3 is 6. 6 times 4 is 24. Yeah? There we go.
Mm-hmm.
This is the information we need to extract. What is the leading coefficient?
24.
There you go. There's a quick pop quiz for you. And we know it's a positive x4. Same thing as x2. It's going to start here. It's going to end here. We don't care about what happens in the middle. So the end behaviors, doesn't matter where x is going, y is going to go to positive infinity, right? Because it's a positive x4. Here's a question for you. 2x2 times 3x minus 4 squared. What's the degree of this polynomial?
Three.
No. So if you think about it, there's 3x squared, yeah?
Mm-hmm.
You can just pull this out. You can pull out a 3x whole squared from this, okay? Then you have a 2x squared on the outside. So you see, what's 3x whole squared?
6x.
No. 3x whole squared means 3x times 3x, not 3x plus 3x.
Oh, so 9x.
9x squared.
Mm-hmm.
Cool? So we have 2x squared from the first one, and then we have 9x squared from the second one. If you multiply, how many x's do you get?
4.
Yes, and you do multiply the number with the number, 18x4. Leading coefficient is 18. The degree is 4.
Mm-hmm.
Do you get that?
Yep.
All right, let's try another one. X times 2x minus 3 cubed. What is the degree? What is the leading coefficient?
Um,
What is the degree? What is the leading coefficient?
is it 8x to the power of 4?
That's perfect. That's exactly what it is. 8x to the power of 4. Degree 4 polynomial, leading coefficient 8, okay?
Okay.
That's all there is to these kind of problems. It's not that difficult. Okay, let's look at this one. It says, does it have an even or odd degree? And then is the leading coefficient positive or negative? Very simple 2-second answers. Well, if you know what you're looking at, basically. For I, is it even or odd? The degree, that's all we're concerned about. Think about the
Odd.
end behavior. I is odd? No, it's not. See, it has the same end behaviors. It's going to the same place, right? This is minus x4, okay?
Okay.
If it's going to the same place, that means it's even. So this is even, and the leading coefficient is negative because it's opening downwards, okay? Let's look at this one, the second one, I. Odd or even?
Even.
Yeah, good. Up or down, positive or negative?
Negative.
Yeah, that is literally all. That is literally all. How many? 1, 2, 3, 4, 5 turning points. So this could be x6 minus x6. I don't know. The third one, even or odd?
Odd.
Yes. Positive or negative?
Negative.
Good. Fourth one, even or odd?
Even?
Yeah, positive. That one's obvious. Let's go to 5, even or odd. This one.
Odd?
Yeah, up or down, positive or negative. They mean the same thing.
Negative?
Yeah. And the 6th one here is odd as well because the end behaviors are different. And it's positive because it's going up. It's opening upwards. By up, I mean, you just look at the right side. Yeah, you just look at this. The fact that this is going up means this is positive. The fact that this is going down means it's negative. Okay, the leading coefficient.
Mhm.
Same thing for the quadratics as well. If you see these guys going up, it's positive. If it's going down, it's negative.
Okay.
Even degree, guys. Okay, it says match. Let's match this with this. How should we do this? Look at equation, small letter a there, small case a. So that's a cubic polynomial, right? Because the degree is 3. Its leading coefficient is positive or negative?
Positive?
Positive, right? So which one could it be? It's degree 3.
Is it C?
It is certainly not C because C is not odd. C is even. If you think about it, you see they're both going to the same place. N behaviors are the same. C is not a. C is an even degree polynomial, okay?
Mm-hmm.
For A, it's cubic. Cubic looks like this, right? It looks like this. So that means it's between B and D because F is negative. It's opening downwards. So how do you know if it's B or D? You look at the y-intercept. You see the 2 there?
Mm-hmm.
There's a cubic polynomial. This is a 1, right? 1 is lower than 2. That means B must be F. Do you see this y-intercept?
Uh-huh.
It's lower than this one here. So this is D must be A. So we've done F and A, okay? That's all there is to
Mm-hmm.
this. Look at B, negative 4x4. Very simple, because if you look at the options remaining, you should be able to tell which one that is straight up.
Is it C?
It's negative 4 means it's not C. C is opening up. It has to be A, no?
Mm-hmm.
Negative means it opens down, right? C is opening up. So no, B must be this one. Okay.
Mm-hmm.
What about this C? Y x squared. This is very, very simple. Tell me which one is C. There's only 3 options. Yeah, exactly. E is C. E must be C. What about D? Now we have 2 options left. Is D C or is D F? It's it's even, right? Even means the end behaviors have to be the same and it's opening upwards. So now think about it. Is D C? D has to be C, right? Because degree 4 means the end behaviors are the same and it's opening up. So D must be this one. That means through the power of elimination, F is E. Another way to look at this is it's negative. Yeah, this is negative here. And it's odd. This is odd because the end behaviors are different. So this must be E, okay? F must be E and you're done.
Okay.
Okay, cool. Don't worry too much about it. We'll do more of this. Eventually you'll get more comfortable with this. Well, let's meet next time.